Okay, let's go ahead and get started. Thank you everybody for attending today. And just a reminder, we are recording this webinar and it is being posted on our Facebook page and our YouTube channel. And today's webinar is presented by our training specialist, Chris Petrik. And before we begin, I would just like to let you know a little bit about Elderwerks. So Elderwerks is a nonprofit organization that helps older adults, seniors, and their families. We provide information, referrals, and guidance for senior living, home care, and other support services. We also provide education on senior topics for both community members and professionals. And the guidance that we provide will help seniors stay home well or transition successfully into a new senior housing opportunity. So if you have questions throughout the presentation for Chris, please use the Q&A button on your screen, and then she will address any questions at the end of her presentation. And also we will have a quick 5-question survey after this webinar is done, and it will open up on your screen. And if you could go ahead and complete that, we would appreciate any feedback you have for us. Okay, I'll turn it over to Chris now. Thank you.
Thanks, Emily. As Emily said, my name is Chris Petrik. I probably have done webinars that you may have been involved in before, but in case you have not, I'm a registered nurse. I have over 40 years of experience in various areas of healthcare. I was a bedside nurse in labor and delivery and other areas of the hospital for about 25 of those years, and then went into education and then found my last calling in older adult care. And that's where I spent the last 15 years. Particularly, I'm working with caregivers who work with people with dementia, because I really felt it was important that people really know how to act with someone with dementia, do it right, be able to meet their needs, and have those people become very successful. You know, in past topics, I've talked about my mom. She had Alzheimer's disease, and I attribute a lot of what I learned in the area of dementia to working with my mom. Today, we're going to talk about understanding the brain, or as I call it, why does something the size of a cauliflower control our whole body? So some of our objectives for today is we're going to talk about the brain as a central control center, learn and review functions of the brain and how it affects our everyday living, the lobes of the brain and their functions, neurons and synapses, what happens really at the core of our brain, type of memory and types of concentration, and what would happen when the brain becomes injured or diseased. The brain is made up of many parts, each with specific and important functions. It controls our ability to balance, walk, talk, eat. It coordinates our heart rate, regulates our circulation and our breathing. It's responsible for our ability to speak, to hear, to view, to process and remember information, make decisions, and our feelings of emotion, or emotions of feeling. Many things have the potential to change the way the brain works. Causes can range from substance abuse, mental health conditions, trauma to the brain, dementia, and environmental factors. You know what, and a lot of us, particularly us older adults, we, you know, our thought process goes right to dementia, because that's what afflicts more of the older adults than any of the other things that can occur to our brain. But we really need to think about people who are living every day with you know, less function of their brain because of injuries. So let's talk a little bit about the brain, the control. It controls many aspects of our thinking. It has remembering, planning, organizing, making decisions, and concentration. The cognitive abilities affect how well we do in everyday tasks and whether we can live independently. Some changes in thinking are common among older adults. For example, older adults may have an increase in difficulty finding words and recalling names, and it doesn't mean that you have dementia. More problems with multitasking, mild decrease in the ability to pay attention. Aging also can have some positive cognitive changes. People, older adults, often are more knowledgeable and have more insight because they have a lifetime of experiences. Research also shows that older adults can still learn new things, create new memories, improve their vocabulary and language skills. Like I said, the brain covers the most work of the body. It has the biggest job, and yet it's about the size of a cauliflower. There's a billion neurons, 1 trillion synapses, weighs about 3 pounds. After the age of 60, the brain shrinks about 0.5 to 1% of its volume each year. And we're going to talk about synapses, neurons, dendrites, and glia in our next slide here. So hang on to your wigs and keys, because this is a lot of information. What I will tell you is, as we progress in this, we're going to talk about concentration. We're going to talk about memories and retaining thoughts. This is a lot of information on this slide, and I'll explain each one individually. But if you were a student in a classroom and I told you we were going to be tested on this, the way we remember and we put things into the little files in our brain would be different than you just listening to this lecture. So just wanted to give you a cue up on that. We'll talk about that in a little while. So neurons, that's the basic working cell of the brain. It's a specialized cell designed to transmit information to other nerve cells, muscles, or glands. Then we have the axon, which extends from the cell body and often gives rise to many smaller branches before ending at nerve terminals. Dendrites extend from the neuron cell body and receive messages from other neurons. And then synapses are the contact points where one neuron communicates with another. The dendrites are covered with synapses formed by the ends of axons from other neurons. When neurons receive a message, they transmit electrical impulses along their axons, which can range in length from a tiny fraction of an inch or a centimeter to 3 feet or about 1 meter or more. Many axons are covered with a layer called myelin sheath, which accelerates the transmission of electrical signals along the axon. MS, multiple sclerosis, is a disease of the myelin sheath. So you can see on a cellular level how, excuse me, different disease processes can cause problems in everyday activities of daily living, like walking, talking, moving, dressing yourself. Glia, also called glial cells, their function is to supply nutrients and oxygen to the neurons, insulate one neuron from another, destroy pathogens, and remove dead neurons. And I had a, let me see. I think I'm going to go back. I think we have a, I thought I had a, I'm sorry, I thought I had a picture of a neuron in here, but it looks like it didn't make it. Okay, so let's talk about lobes of the brain. So we have the frontal lobe, which is orange, the temporal lobe, which says it's pink here and it's not. Just ignore the colors there. The frontal lobe is orange, and in the frontal lobe we have the motor cortex. So this is where a lot of our movement. In this cortex, near between the frontal lobe and the parietal lobe, we have the sensory cortex. So that would be where maybe our sensory memory is stored. That's where part of our vision and our hearing is initiated. Then we have the parietal lobe, and then we have the occipital lobe, and again, ignore those colors there, is yellow. And I'm going to explain each of these lobes individually. The cerebellum down here, which is really the control for your breathing, your involuntary things that your body does. Down here is your brainstem. This green structure here is your temporal lobe, and that temporal lobe plays a lot. Has an important function too, and then what we call our olfactory bulb, and our olfactory bulb has everything to do with smelling. One of the structures of this part of the brain is the sound and how sound gets picked up. And you know, sometimes the reason I show these little videos is because the transmission of sound is so complex. Yet we take it for granted, we don't even think about it. But there's so many areas that can go wrong with sound before it hits that temporal lobe. And again, Emily, let me know that.
Have you ever wondered how sounds make their way from the source all the way to your brain? Take a trumpet, for instance. When it's played, it makes sound waves in the air. The outer ear catches the waves, which then travel through a narrow passageway called the ear canal. The sound waves reach the eardrum, which is a membrane roughly half the size of a dime. They make the eardrum vibrate, which in turn vibrates 3 tiny bones called the malleus, incus, and stapes. These bones amplify or increase the sound vibrations and send them to the cochlea. The cochlea is shaped like a snail and is the size of a garden pea. It is filled with fluid, and the sound vibrations make this fluid ripple, which creates waves. Hair-like structures called stereocilia sit on top of hair cells and are grouped together as hair cell bundles inside the cochlea. The hair cells inside the cochlea ride these waves, and the hair bundles are moved. The hair bundle on top of the hair cell turns these movements into electrical signals. As the hair bundles are moved, ions rush into the top of the hair cells, causing the release of chemicals at the bottom of the hair cells. The chemicals bind to the auditory nerve cells and create an electrical signal, which travels along the auditory nerve to the brain. Different hair cells respond to different frequencies of sound. The hair cells at the base of the cochlea detect higher-pitched sounds, such as a piccolo or flute. The hair cells toward the top of the spiral detect progressively lower-pitched sounds, such as a trumpet or trombone. At the very top or apex of the spiral, the hair cells detect the lowest-pitched sounds, such as a tuba. The auditory nerve carries the electrical signal to the brain, which interprets the messages as sounds that we recognize and understand.
Again, I vet a lot of these videos because I know, especially with online learning, just listening to someone for an hour can be kind of droning and disappointing. But, you know, I look at a lot of these videos because I know there's different type learners out there. And when we get into memory and concentration, you'll kind of understand that. But what I liked about this video is, again, it really shows the pathway and the milliseconds that it takes for that to happen. And yet it's something that we take for granted. Also, many of you out there may have a hearing loss. I do myself. My hearing loss is at the very top of the apex because I'm missing lower sounds. So when you get tested and they tell you where your hearing loss is, they may say it's the higher pitch or the lower pitch. Mine's at the lower pitch. Also, as it mentioned, the cochlea, you may have seen in your lifetime someone wearing what they call a cochlear implant. Now, take a minute to think back about those little cilia and then those bundle of hairs on top of that cilia. And that's, you know, part of the cochlea. So there's something that must work between that cochlear implant and that part of the brain. Just kind of interesting. So let's talk about the function of each lobe. This is the part of the brain that controls attention, concentration, self-monitoring, organization, speaking, motor planning, and initiation. Let me talk about those a little bit, the self-monitoring. So self-monitoring is really identifying what you can and cannot do, what you can and cannot say, if it's appropriate or not appropriate. Motor planning and initiation. I can make a decision to get up and get a glass of water, but then my body has to actually process that movement. So when we talk about an initiation, it really is defined as the ability to organize the body's actions, knowing what steps to take and what order to complete a particular task. We use motor planning for all physical activities, including everyday tasks like brushing our teeth or washing our hands. Mental flexibility is cognitive flexibility is an area of the brain called the anterior cingulate gyrus, the ACG, and that tends to be overactive in people who have difficulty with cognitive flexibility. That's actually located in the front part of the brain, and it's involved with shifting our attention. When the ACG works well, it allows us to focus on something, let go, and then shift onto something else. However, when it's overactive, there's a tendency for people to get stuck. Awareness of abilities and limitations, safety awareness, is having the ability to identify what you can and cannot do, what is safe for you and what is not. Often this process, someone will lose sight of that, and it will be difficult for them to remain independent. Examples of safety awareness would be someone driving a car when they're no longer able to do that, or not using their walker or their cane when it's appropriate when they're getting up to ambulate, or using a step stool without any support to get something from a higher cabinet. Sequencing and organization, processing information, such as predicting the consequences of an action. So if I do this, this is going to happen. Understanding the concept of time, executive function, which we'll also talk about, and then coping with daily tasks like tidying up or cooking. So this is attention, and there are 4 types of attention that get processed in the brain, specifically in the frontal lobe. First, and not in any particular order, is sustained attention, which is one's ability to focus on one specific task for a certain amount of time. And the example is reading a book or putting a puzzle together. Next is selective attention. And again, like I said, not in any particular order, the ability to select from factors of stimuli that are present at the same time. So it's really the ability to filter out noise or distractions in a room. It would be, for example, Emily said that at the beginning when we were just getting on, there was some noise in the background. You would be, and hopefully there is not anymore, but you may have that attentional ability to remove that noise and listen to what is being said. Another example would be talking to someone maybe at a wedding while the band is playing, or sitting in a park talking to someone while a parade marches by. Alternating attention is the ability of mental flexibility that allows the ability to switch back and forth between tasks that require different cognitive demand. And that uses different parts of the brain. So for example, cooking dinner while you're helping your child or grandchild with homework, or reading a recipe, which is actually a learning part of your brain, then cooking the recipe, which is actually the doing part of your brain. And then last, divided, and that's the ability to respond or react to 2 or more different demands simultaneously. That's really our multitasking. And that's maybe talking on the phone while getting dressed, talking on the phone, talking with your friends while making dinner. Those would be examples of divided attention. And this little video is going to talk about that a little bit more.
People are constantly bombarded with stimuli, sights, sounds, odors, feelings, and in order to zero in on any of them, we rely on attention, focusing on a specific stimuli in our environment. Specifically, we engage in selective attention by choosing certain stimuli in the environment to process while ignoring the rest. Like how people turn down the car radio when they're looking for a particular road or address. But sometimes we also need to exhibit divided attention, where we attend to multiple sources of information at once. A popular example of this is the cocktail party effect. Have you ever been at a party, engaged in a conversation with someone cool, and then you hear someone mention your name across the room? You become aware of it almost immediately, even though you weren't paying conscious attention to it. In this case, your name triggers selective attention, causing you to filter out the other stimuli upon hearing your name. This can be mimicked in the lab using a dichotic listening task. In this task, a listener wearing headphones receives a message in the right ear and another in the left. The listener is asked to attend to only one of these messages and repeat it word for word. Afterwards, they are quizzed on the material that was played in the non-shadowed ear, the one that they weren't attending to. Individuals can typically remember only superficial aspects of the non-shadowed message, such as whether the speaker was male or female, the number of people speaking, and a little bit about the topic of the message. But regardless of whether they are consciously aware of it, some aspects of the message still come through. For example, the listener's interpretation can be influenced by what is played in each ear. If the sentence, "they were throwing rocks at the bank," is played in the shadowed ear, the word bank is more likely to be interpreted as a financial institution if the word money is simultaneously played in the non-shadowed ear. If the word stream is played in the non-shadowed ear, the bank is more likely to be interpreted as the side of a river. Our attention isn't perfect. People are both unaware of many aspects of their environment and blind to that lack of awareness. Inattentional blindness is the failure to notice an unexpected object or event when one's attention is focused on something else. This has been demonstrated in many rather humorous studies. In one study, people were told to count the number of times folks wearing white shirts in a video passed a basketball. Then, in the middle of the video, a guy in a gorilla suit walked straight through the scene. They were so focused on counting the number of passes, half of the viewers failed to notice the gorilla. Half! It's easy to laugh at this, but this lack of awareness can actually have some far-reaching consequences, like when drivers fail to notice pedestrians or cyclists because their focus is elsewhere. Another example of our lack of awareness is change blindness, the failure to notice a change in a stimulus event. For example, did you notice anything that changed over the course of this video? It's kind of hard to notice change, especially when we don't see it coming.
Kind of fun. I'm going to ask you how many of you, and you can just put it in the in the chat. How many of you noticed that that her outfit changed? Oh, Vasim, you're good. Anybody else? Okay. Well, the people that did notice the change, you've got great visual awareness. Good for you. I watched it and did not see the change until after she noticed it. And then I watched it again because I wanted to see exactly when the change occurred. But, you know, if we're not paying attention, I was really listening more to what she was saying than really looking at her. So if you didn't see the change, there's nothing wrong with you. It's just someone has maybe more a little astute visual awareness than someone else. Okay, so concentration really is the brain's ability to focus your mind on a single thought or a task. The cerebral cortex is the part of the brain that is associated with our memory, thought, concentration, awareness, and consciousness. This is also where concentration comes into play. With everything we do, there is a certain amount of concentration that takes place. The process of concentration is a very important part of what we do on a daily basis. Without the ability to concentrate, thoughts could be lost and memories wasted. If you're eating ice cream, you are most likely thinking about or focusing on the taste and the texture, and possibly the fact that you will have more when you're finished. When you're reading a newspaper or your favorite magazine, you're concentrating on the words and details that bring the articles to life, and finish up with a nice crossword puzzle. Just as you read the text for this class, you are stimulating your brain and putting forth an effort to concentrate. And, you know, when I was doing a lot of research for this, there is a lot of study being done in this area, especially with kids with ADHD. Because this is really the part of the brain that they're having difficulty with, is the cerebral cortex. And, you know, so a lot of the videos that I looked at were based to children. And actually the one that I will have later on that you'll see really is based more towards children, because once the person understands where the deficit is, they can work on it. Because remember, our brain has the ability to create new neurons and synapses. Okay, so we're going to talk about the different types of memory, but I want you, this is pretty complex too, but I want you to think these three that surround the big purple memory here is really the most important, because off of those come other things. So we're going to talk about sensory first. Sensory holds onto perceptual information for a very brief moment. Sensory is thought to provide the initial storage for information about what a person has just perceived. So the first thing is we take in information from our sensory memory. Then from our sensory memory, it gets moved to short-term memory, and we'll talk about that in a minute. And then from short-term memory, it gets vetted again, and it decides if it goes into long-term memory. And we'll talk about these memories in a minute. Next is short-term memory. It's the information that we're currently aware of or thinking about. So what we're doing right now would be the short-term memory. Your sensory memory is looking at this, the schematic, and it's looking at the different colors, and it's giving you information, and you're deciding after it goes into short-term memory whether it's important enough to go into long-term memory or not. Short-term memory is very brief. When short-term memories are not rehearsed or actively maintained, they're there just mere seconds. But otherwise, it's limited to about 15 to 30 seconds. And if we look at sensory memory, it's just several seconds. So it's even shorter than short-term memory. Short-term memory is also called working memory. And working memory is really, it stores and processes information at the same time, which is why it's called working memory, because it's working, it's storing, and it's processing the information. Long-term memory is the storage of information over a period of time, which could be days, weeks, or years. And inside of short-term memory, we have implicit and explicit memories, which are part of long-term memory, which is why they're also colored yellow for you. Explicit memory is conscious thought, such as recalling who came to your dinner party last night, or naming animals that you might see in a zoo. Explicit memory is often associative. Your brain links memories together. For example, when you think of a word or occasion, it's going to start stimulating thoughts of a past memory. So for example, if your granddaughter is getting married, you might trigger that thought to what your own wedding day would have been, was like. Implicit memory, also called non-declarative memory, is a type of long-term memory that doesn't require conscious thought. It just allows you to do things by rote, which is actually, if you look next, it's really part of implicit memory. Procedural memory enables us to carry out commonly learned tasks without consciously thinking about it. It's really the how-to knowledge, such as riding a bike, putting our shoes on, tying our shoes, washing dishes, really all the tasks that require procedural memory. Even what we think of as a natural task, such as walking, is considered procedural memory. You know, as I was putting this together, I was thinking of this procedural memory, and again, so there's the explicit memory, but I remembered back to when my mom was just starting to show signs of Alzheimer's at that point, and she was living in an independent living with some services. And I was working full time, and I couldn't get out except on Saturdays to see her. And when I went on Saturdays to see her, she had dishes piled up in the sink. And my first thought, and again, at that point, I didn't realize, because I didn't know at that point, that she was probably starting to lose some of her procedural memory. Because if you think about washing dishes, there's a procedure to it. We just take it for granted. But as I was talking to my husband last night about procedural memory and washing dishes, you turn the water on, you fill the sink, you put soap in, then you put your dishes in. And if you're like me, you put your dishes in a certain order. You go from cleanest dishes and cups to dirtiest silverware before the dirtiest pots and pans. So there's a sequencing of events, and then you let them drain, you rinse them, you let them drain, and then you dry them. This procedural memory was something that was lost with her. And my first thought at the time was, is mom getting lazy? I have to be honest with you. I thought, what's going on here? Until I realized she was losing that procedural memory. And so especially with driving, that's something that has been embedded for a very long time. And you might still have that procedural memory, but then there's something that is also called executive function, which we'll talk about. Declarative or explicit memory is a subcategory of long-term, and it's used for learning facts and events. This type of memory plays a vital role in rapid learning. As the name suggests, this type of memory can be declared. Therefore, these memories can be called consciously. Episodic memory refers to a memory gathered from the day-to-day experiences. And then semantic is general world knowledge that we have accumulated throughout life. So really, just if you are going to remember anything, remember that sensory starts it all off. Then it goes to short term. Then it goes to long term. And from long term, it goes to either here or there or both of them. Then it goes to declarative. If it's an explicit, then it goes to procedural, which are all those basic things that we do every day: riding a bike, doing dishes, brushing our teeth, tying our shoes. Then it goes to semantic and then episodic. Okay. I'm going to go back to that slide because I want to show you this little video, and this shows us how sometimes and it gives you more insight into the brain.
Think back to a really vivid memory. Got it? Okay, now try to remember what you had for lunch 3 weeks ago. That second memory probably isn't as strong. But why not? Why do we remember some things and not others? And why do memories eventually fade? Let's look at how memories form in the first place. When you experience something, like dialing a phone number, the experience is converted into a pulse of electrical energy that zips along a network of neurons. Information first lands in short-term memory, where it's available from anywhere from a few seconds to a couple of minutes. It's then transferred to long-term memory through areas such as the hippocampus, and finally to several storage regions across the brain. Neurons throughout the brain communicate at dedicated sites called synapses using specialized neurotransmitters. If two neurons communicate repeatedly, a remarkable thing happens. The efficiency of communication between them increases. This process, called long-term potentiation, is considered to be a mechanism by which memories are stored long-term. But how do some memories get lost? Age is one factor. As we get older, synapses begin to falter and weaken, affecting how easily we can retrieve memories. Scientists have several theories about what's behind this deterioration. From actual brain shrinkage, the hippocampus loses 5% of its neurons every decade, for a total loss of 20% by the time you're 80 years old, to the drop in the production of neurotransmitters like acetylcholine, which is vital to learning and memory. These changes seem to affect how people retrieve stored information. Age also affects our memory-making abilities. Memories are encoded most strongly when we're paying attention, when we're deeply engaged, and when information is meaningful to us. Mental and physical health problems, which tend to increase as we age, interfere with our ability to pay attention and thus act as memory thieves. Another leading cause of memory problems is chronic stress. When we're constantly overloaded with work and personal responsibilities, our bodies are on hyper alert. This response has evolved from the physiological mechanism designed to make sure we can survive in a crisis. Stress chemicals help mobilize energy and increase alertness. However, with chronic stress, our bodies become flooded with these chemicals, resulting in a loss of brain cells and an inability to form new ones, which affects our ability to retain new information. Depression is another culprit. People who are depressed are 40% more likely to develop memory problems. Low levels of serotonin, a neurotransmitter connected to arousal, may make depressed individuals less attentive to new information. Dwelling on sad events in the past, another symptom of depression, makes it difficult to pay attention to the present, affecting the ability to store short-term memories. Isolation, which is tied to depression, is another memory thief. A study by the Harvard School of Public Health found that older people with high levels of social integration had a slower rate of memory decline over a 6-year period. The exact reason remains unclear, but experts suspect that social interaction gives our brain a mental workout. Just like muscle strength, we have to use our brain or risk losing it. But don't despair. There are several steps you can take to aid your brain in preserving your memories. Make sure you keep physically active. Increased blood flow to the brain is helpful. And eat well. Your brain needs all the right nutrients to keep functioning correctly. And finally, give your brain a workout. Exposing your brain to challenges like learning a new language is one of the best defenses for keeping your memories intact.
Okay, one of the, I'm gonna go back to this for a minute. One of the other reasons that I also use videos is for sensory, because I know that that's where things begin. And just listening to someone, it stimulates the auditory, but it doesn't stimulate the visual. And so a lot of times, when I'm looking at videos, I never pick a video where someone's talking, because that's going to be just like me doing the same thing. But there are things that we can do to improve our memory. And I know one of the questions that I've been asked before is, do those medications that they talk about help memory? And I have to tell you that the jury's out on that they say there's no scientific proof. However, when you talk to people and they say that their memory has improved from taking the memory medications that they talk about on TV, that there is some improvement. If you are someone that takes that and you think there's been some improvement, put that in the chat box or the Q&A, and at the end, and we'll kind of address that again. But back to our slides, the function of each lobe. The spatial ability or perception is the ability to be aware of your surroundings. Depth perception is really the ability to see things in 3D and how far away they are. Proprial perception is really the ability to figure out where you are in space in a room. Your sense of touch, spatial perception, depth perception, and visual perception are located in what's called the parietal lobe. Injury to the parietal lobe can lead to problems with the 5 senses. The occipital lobe is where your vision is located. If you have an injury to this part of the brain, you may have difficulty seeing or perceiving size, shapes of objects. And then the cerebellum is where our balance and coordination is initiated. Also in the cerebellum is skilled motor activity, visual perception. So an injury to this area may lead to difficulties with balance, movement, and coordination. I know I talked about the 5 senses being in a different part of the lobe, and I think that's Mother Nature's way. Some of the actions of a different part of the brain may spill over into a different lobe, and I think that's how you have, when you have a brain injury, sometimes instead of losing all that function, that other part of the brain, and again, this is my assumption, but I think that other part of the brain would take over. And I think that's why you'll see some functions being in maybe 2 areas of the brain. Lastly, the brainstem controls the body's involuntary functions that are essential for survival, such as breathing and heart rate. Okay, we saw that, so we're going to skip that. Let's talk about being right and left brained. There are certain traits that coexist with someone who's left brained. And let me first say that whether you figure that you're right or left brained, we definitely use both sides of our brain, but we do have one that's more dominant than the other. And that's why we say we're right brained or left brained. I really think I'm more right brained than left brained. And we'll see what you think, where you fall in. You may know this already, but a left brain traits are, those people are typically more analytical, more logical, more precise, they're more organized, they are considered more detached, and they're more literal. So if you said, let's jump into bed, if you said that to someone you're caring for and they're more literal, they're going to take that literally. They'll have probably to decipher that in that part of their brain and say, she doesn't really mean hop into bed. She means get into bed. So what can happen when part of the brain, that part of the brain is damaged? You might have difficulty understanding language. You might have impaired logic. You may have a hard time speaking, hard time sequencing. You may have extreme emotions where you're very happy and then very sad, and you may have decreased control over the right side movements of your body, because the right side of your brain helps move the left side of your brain and vice versa. Okay, so our right-sided traits include creativity, imaginative, intuitive, conceptual, empathetic, and figurative. Injuries to the right side would cause visual spatial impairments, neglect to the left side of the body, which we call hemoneglect, decreased awareness of one's deficits, altered creativity, and music perception. Kind of loss of the big picture type of thinking as well, and decreased control over, like I said, the left side of the body. So there's two examples I want to cite here. My father-in-law, who's now been deceased for quite a long time, but he had a stroke, and it was on the right side. So he had the left side hemoneglect. And one of the ways they tried to get him to connect, and he wasn't aware of the left side of his body not working. So one of the things that they tried to get him to do was name his left hand, because if he named it and he knew it was, had a name and he knew it was there, they were trying to make those connections to the brain. Obviously for him, it did not work, but for a lot of people who have a paralysis or have had an injury, they may suggest that they do that. The other thing that I wanted to mention when I talked about music perception, so a friend of mine who's a preschool teacher and loves music had a stroke related to atrial fib. So they fixed the AFib and they put her on blood thinners, and she was fine until she went back to work, and they put on music, and she said it was like nails on a chalkboard to her. How her brain was perceiving that music was very difficult for her. And this is someone who loved music, particularly classical music. So when she went back to the doctor, and she said, I think I'm doing fine, except I have this really weird feeling every time I hear music. It drives me over the edge because it sounds so weird to me. The doctor got all excited and he called it something, and it had something to do with the damage in that part of her brain. And he did tell her that probably would go away as the brain healed. And of course it did, but he wrote it down, and I don't remember the name of it, but he said it's pretty unusual, but that can happen. So again, just different ways that our brain controls everything that we do. And now we're coming to executive function, which is described as a set of thought processes and mental skills that help a person plan, monitor, and effectively execute their goals. These include attention control, working memory, inhibition, problem solving, behavior planning and organization, fluid intelligence, reasoning, and inhibition control. It allows individuals to differentiate among conflicting thoughts and filter out unimportant information. It also helps the individual anticipate the future consequences of current activities and work towards a defined goal. Any process or goal pursuit that results that requires time management or decision-making and storing information in one's memory makes use of our executive function to some degree. Executive function is among the slowest mental processing to develop. So they did a lot of research on executive function, and they found that for males, executive function really doesn't reach its potential between the ages of 25 and 30. And for females, between their late teens and mid-20s. So what that's saying is the decisions that people might make as young adults may not be appropriate. That's why we see a lot of drinking in college. That's why we see a lot of, with this COVID, with a lot of these kids going to their first year of college, ignoring everything that everybody's saying about it, and they're having these big parties. They, although we blame them for acting inappropriate, we have to sit back and say, what part of the brain is making those decisions? And it's part of the brain where the executive function is, and it's not developed. So, and like I said, for men, it's not developed until later. So we're going to see drinking and driving, and the unlawful use of arms and guns. So something we need to think about when we're giving people permission to do things. Again, why people in that age group text and drive, because they really don't have the ability to think more at a higher executive function. It just shows you here that it's initiated in prefrontal regions of the frontal lobe, which is called the dorsolateral prefrontal cortex, the anterior cingulate cortex, we've heard of that before, and the orbital frontal cortex. So that is where it is initiated. They're also looking at a lot of this executive function when they're looking at people with Asperger's or people who are on the spectrum. So again, here's a short video about executive function, and in this one, although I think it explains it quite clearly, obviously is something that's geared towards children, but this was the one that I thought was most clear about really what executive function is.
Do you find your child to be disorganized? Do they have trouble focusing on more than one thing at a time? And what's up with them not remembering any of the instructions you just gave them? Expecting that your young child will be as organized as you or have as much focus as you is not quite developmentally accurate. When your child reaches preschool age, they are just starting to exhibit the skills of executive function, and it is your job to help nourish that growth. What is executive function? Executive function is a set of mental processes that enable us to plan, focus attention, remember instructions, juggle multiple tasks successfully, and link past experiences to the present. To better understand this concept of executive function, let's take a look at what is going on within the brain. It all starts in the prefrontal cortex of the brain, which is the most advanced part of the brain. In humans, it makes up almost the whole front third of the brain. It helps monitor and regulate your emotional circuits and habit circuits. For example, if a person is mad and their immediate reaction is to scream and throw punches, the prefrontal cortex allows them to come up with a more productive reaction, like explaining their feelings or taking some deep breaths to calm down. This part of your brain is also in charge of planning and getting stuff done. This can range from devising a little white lie or plotting revenge to going to the bathroom or planning a trip around the world. Importantly, it is also the slowest part of the brain to develop, continuing to mature until your mid-20s. So it's highly influenced by experiences, especially during the preschool years. A child is not born with executive function skills, but they are born with the potential to develop them. The skills of executive function depend on 3 different types of brain functions that are primarily mediated by the prefrontal cortex: working memory, mental flexibility, and self-control. Let's break each of these 3 skills down. Working memory is the ability to retain and use distinct pieces of information over short periods of time. Mental flexibility is the ability to sustain or shift attention in response to different demands or to apply different rules to different settings. Self-control enables us to set priorities and resist impulsive actions or responses. As you can see, the 3 executive function skills, working memory, mental flexibility, and self-control, affect almost every aspect of our day. Realizing that children are still learning and not just being bad can be a refreshing perspective for us adults to remember.
So that really, again, although it was geared towards children, I think it's enlightening to see that a couple of things. First of all, we're not born with executive control, that it needs to develop. And that sometimes when we see maybe our children, grandchildren, or our spouses or someone we know that may have a disease process such as dementia, do something inappropriate or not pay attention to something, we know it's because of that part of the brain that is diseased. So we're going to talk about injuries and diseases that can cause havoc with the brain. There's about 50 to 100 types of dementia. It really depends on who you talk to. The most common is Alzheimer's disease, frontotemporal dementia, Lewy body, and vascular dementia. Some of the less common diseases are Creutzfeldt-Jakob disease and other prion diseases, Parkinson's disease dementia, dementia in HIV and AIDS, and Huntington's disease, and something called Wernicke's Korsakoff syndrome. So again, those are categories of the different types of dementia. Remember that dementia is a kind of an umbrella term for the different types of dementia that are listed below that. So it's a group of syndromes and symptoms that fall under the umbrella of dementia, and then we look at the different types of dementia. So Parkinson's disease dementia is a progressive nervous disease order that happens when nerve cells in the brain control movement. They begin to die, causing insufficient production of dopamine, and that's a brain chemical that releases, and that depletion causes change in how you move and act, and how you walk and talk. Over time, other symptoms develop, and some people will then develop dementia. Not everybody who has Parkinson's disease will develop dementia. Huntington's is a progressive brain disorder which causes cognitive difficulties, uncontrolled movements, emotional disturbance. It is a genetic defect and usually starts showing symptoms. People start showing symptoms in their anywhere between 20s or 40s. It's a pretty devastating disease. And then Creutzfeldt-Jakob disease is a degenerative brain disorder that leads to dementia and ultimately death. Symptoms of Creutzfeldt-Jakob disease can resemble those of other dementia-like disorders such as Alzheimer's. The difference with Creutzfeldt's is that it progresses more rapidly. I know someone who was diagnosed with Creutzfeldt-Jakob, and it's not that common, so it was a very difficult diagnosis. She ended up downtown at Rush, and took about 2 weeks to really figure out what that diagnosis was. She was diagnosed on Father's Day, and she died right around Labor Day. So it's very progressive, usually about 6 to 18 months for that. And then Wernicke-Korsakoff syndrome is caused by alcohol use. So those are some of the dementias. Then we have traumatic brain injury, which I'll talk about in a minute, brain tumors, neurological diseases such as cerebral palsy, progressive supranuclear palsy, and epilepsy. So traumatic brain injury and dementia comes from blows or jolts to the outside of the head caused by assaults, infections, and accidents. There are many causes of traumatic brain injury. The one that is in the news a lot is chronic traumatic brain encephalopathy, which is caused by recurrent concussion. So we are starting to see some of our football players and our hockey players and our soccer players have CTE. Some of the professional football players that were diagnosed with CTE is Mike Adamle, Brett Favre, Dave Durrison. Dave Durrison was actually committed suicide to a gunshot to the chest because he knew that he had CTE, and he knew he was losing his memory, and he wanted his brain donated to science so they could investigate it. So we're also seeing an influx in brain injuries caused by closed head traumas seen in combat, and because war is much more sophisticated and powerful than it was in other wars, we are seeing an increase in closed head traumas with similar symptoms as seen with dementia and mental illness. So a little bit about Alzheimer's disease. This just shows you what a healthy, remember when I said the brain shrinks anyways in age, but with Alzheimer's disease, you go from a brain that's about 3 pounds, it usually goes down about 1 pound, and then in Lewy body, it goes down even farther. The hippocampus is where we see a lot of the damage, and that is where a lot of our memories are stored. So there's a lot of memory loss with Alzheimer's disease. This is just a picture of a non-diseased brain, a picture of with someone with Alzheimer's disease, and then you can see the shadow, you can see the shrinkage of the brain. But take a look at the texture of the brain. This one looks nice and pink and spongy, and this one looks hardened and darker. And that's because the pathology of Alzheimer's disease is what we call plaques and tangles, and so there's a dying off of the brain tissue. So again, I'm going to go back and just kind of review if we have any of the issues in this function of the brain. If we have a closed head trauma, if we have a brain tumor, if we have dementia, we're going to have difficulty with attention, concentration, what we call self-monitoring, organization, speaking, motor planning and initiation, awareness of abilities and limitations, personality, and mental flexibility. So these are the people that may have some difficulty with their activities of daily living. They may also have difficulties with communicating with people because they may not be able to speak as other and have other people understand them. They may have difficulty with motor planning and initiation. You'll see that in Parkinson's. When someone gets up to walk with Parkinson's, they may, their brain is telling them to move, but you'll see those feet are planted on the ground and they're kind of moving back and forth to get that body moving forward. You may see changes in their personality. You may see some hypersexuality to them. You might see mental flexibility changes where these people have to have a specific schedule, and they have to be able to follow that schedule to make their life happy. Temporal lobe, again, in the hippocampus, you're going to have problems with memory. Also, that's where language can be initiated as well. So you're going to have problems with understanding language. Sequencing, so this is someone who's putting their shoes on and then putting their socks over their shoes. And we see this. This is not unusual, and that's why we have caregivers to help them. They'll have difficulty with hearing, and they'll have difficulty with organization. And then in these, the parietal sense of touch, spatial perception, depth perception, identification of sizes, shapes, and colors, visual perception. So they're going to have problems with proprioception. They're not going to know they're correctly in that space. If you notice any caregivers, if you've seen them get someone to a chair and they'll say, touch the chair on the back of your legs. And that's so that sense of touch maybe clicks in, and so they know they're close enough to the chair to sit down. Because if they're having problems with spatial perception or depth perception or proprioception, they may not see that chair as being close or far. They may see it as being close, and when they sit, they may end up on the floor. Obviously, as we get to the last stages of life, whether it would be from a head trauma or from dementia, we're going to see changes in consciousness and arousal. And when we talk about arousal in this arena, we're not talking about sexual arousal. We're talking about people sleeping and not sleeping a lot and not being able to awaken. We'll see changes in heart rate, and we do see changes in circadian rhythms. We also see changes in balance and coordination, skilled motor activity, and visual perception. So really, if you think that the brain were that simple, we could understand it, we would be so simple that we couldn't. And that's a quote by Lyle Watson. I don't know who that man is, but he says it exactly as it is. It's very, very complicated. And if we understood everything that we could about it, it'd have to be simple enough. Otherwise, we wouldn't be able to understand. So it looks like we're about closing time here. And I'm going to go into chat and questions and answers. And how does domestic violence cause brain injury? A lot of times they get punched in the face and the head. that's, that would cause it. Repetitive, someone who stays in, especially stays in domestic violence, it's like the football player getting kicked in the head all the time during his football games or hit in the head. So that's really how traumatic brain injury works. What games are good for improving memory? Really just about any game. And I think it's important to really exercise your brain. There's a lot of memory brain, there's Brain Quest, which is online. And there's a lot of games that are out there that would improve your memory. Doing crossword puzzles. There's a game that I play with my grandkids, and it is, find the matching fruit. Obviously it is for a 3 or a 4-year-old, but they love playing it. But I have to say, I find myself excited when I know where exactly all the fruits are. So it's helping short-term memory, even though it's at a 3-year-old level, and I'm playing the game with a 3-year-old, I'm still exercising my brain, and that's really the important thing. Yes. Any other questions?
We have a question in the chat box. Do you see
Okay,
that?
let me go to the chat. I apologize that the video and audio were out of sync. It didn't sound like that at my end. And I'll tell you, the reason that's distracting is because you have 2 sensories working at the same time, and in your brain, they're not matching up, Mary. So I do apologize for that. I don't know why they, on your end, they were not matched up. But I can tell you the fact that you were annoyed by that is simple. It's really, you're taking in the visual and you're taking auditory at the same time. And when it gets to that part of your brain to make that sense, it's not connecting. For after your presentations regarding brain shrinkage, aiding bend, and anything to accelerate this or to help decrease it. I think, what we've learned across the years is if the brain is not diseased, like with Alzheimer's disease, if you have a healthy brain but an aging brain, any type of physical activity will bring more oxygen to the brain, and anytime there's more oxygen to the brain, you are bringing more nutrients to the brain and feeding those neurons, those dendrites. You're getting a better health in the brain. Also, socialization is extremely important, and I think in this period of isolation, it's been very difficult for all of us, especially our older adults, because we might be beyond that technology that can bring us together. But getting together even on Zoom with some friend of yours and having a conversation, even though we can't feel and touch them and have them in the same room, we're still connecting those brain signals. They've done studies on people who babysit for their grandchildren have more active brains than people that don't. So if you have a grandchild and you've been asked to babysit, volunteer to do it, it really helps, get those generate those brain cells. So doing brain exercises, like I said, Brain Quest, or there's a couple of them online that you can use. Sudoku. If you used to do it, I can't do Sudoku. It's a math thing, and I'm not that maybe left brain to do that. So, that would just frustrate me, but I do crossword puzzles, I do jigsaw puzzles on my iPad. Anything that gets me thinking, you're connecting synapses. And I had mentioned this at a last one, something as simple as combing your hair with the opposite hand, your non-dominant hand, or brushing your teeth with the non-dominant hand, is going to create a synapse. So, today before you go to bed and you brush your teeth, if you're right-handed, try your left hand. It's developing a synapse somewhere. So doing something that's unusual for you will help develop a synapse. Anybody else? Can a brain injury affect all parts of the brain? Yes, it can. Because it depends on what kind of brain injury it is. But if that brain was rattled back and forth, like if you were in a car accident and your brain hit the steering wheel and hit back, that brain is moving back and forth, and it's causing inflammation to that tissue. So yes, it can. I had a friend that was in a car accident in her mid-20s. She and her husband were going on vacation, and they were driving all night. So she laid down, her head on his lap, or close enough to the steering wheel, I should say, and a semi pulled out and hit them. And she had significant brain trauma, and it took years for her to regain. She was a registered nurse. She had her master's in nursing, very smart lady. And she really damaged her olfactory nerve. She could not smell anything it was almost 5 years. 5 years later, she had a baby in between that 5 years. And the first thing she was able to smell in 5 years was the baby's dirty diaper. And then she realized, oh my God, I could smell that diaper. So, that does heal over time for many of those traumatic brain injuries. Some of them don't, and it can cause to that CT encephalopathy and go on to dementia. So, but yes, it could. Anybody else?
We have a few questions in the Q&A.
Can a long surgery being under anesthesia cause brain injury? It doesn't actually cause brain injury, but it really can mess with your brain a little bit, especially when you're older. We find that with older adults, after they come out of surgery, they might be very confused for as long as 6 weeks after surgery. So, I don't think it causes injury to the brain, but I think it changes something in there temporarily, where there are significant changes to someone. And typically when I was working in long-term care and someone was going for surgery, and I was, talking to the family, I would say, don't be alarmed if mom comes out of surgery and she seems a little confused. And that confusion may take people about 6 weeks, for them to retrieve that. Are people born without the ability to smell? My sister has never had the sense of smell. I suppose it's possible, and you're a living witness to that. Maybe she's missing her olfactory nerve. What they do find, and this has nothing to do with your sister, but what they do find is that one of the very first signs of dementia and of Alzheimer's disease, and in retrospect, is a loss or a diminished sense of smell. But since your sister never has had smell, she's missing the good and the bad and the ugly, I suppose. She's missing the flowers. She's missing the smell of fresh baked bread, and she's missing the smell of poopy diapers. So, there's a lot to be grateful for and a lot to be disappointed in that. But if I had to take a guess, and I'm not a clinician in any of this, I'm a nurse and I have basic knowledge, so we'd have to really talk to a neurologist about this, but I would say it probably starts in her olfactory nerve. So what if you're under anesthesia for surgery multiple times in a short period, such as twice in 6 months or twice in 2 days? I know, Mary, that, and again, it causes confusion, and I think it's really the drugs itself that they use for anesthesia that causes the confusion, and it takes a long time for us to get those washed out of our body. And that's what I would think would happen. And it is risky to have multiple surgeries in a couple of days, but sometimes it's necessary. Will COVID brains and other organs be affected in the future? Good question, Yasim. And I just read an article this morning about a new finding that, they talk about something called the ACE receptors, and that's where the COVID, kind of likes to set up shop. And the ACE receptors are in your lungs and your kidneys and in your gut. And that's why people are having, kidneys regulates your blood pressure. So that's a problem there. And a lot of people have these GI symptoms, and a lot of people have issues with smell and confusion and stuff after that. What they're looking at right now is the long-term effects. What they did find is, and I just read this article this morning before we came on, that there's another chemical that we have in our body called bradykinin, and bradykinin helps regulate some of those areas in our body also. But when they're messed with COVID, what they tend to do is make the fluids in our body kind of turn to gel. And that's why people who are on ventilators sometimes don't do well like we anticipate, because you're working against a substance that's thicker than, so it's a very thick mucus. And some, they kind of mentioned it's like putting Jell-O in your lungs and expecting you to breathe through that. So they are seeing some cardiac, people who are having longer cardiac issues and other organ issues, but I think the jury is out. I think we will be learning more about that. Any other questions? Thanks, Charlie, for the slides. I like to, again, it's very visual, and that's just, working another part of our brain. Well, thank you, everybody, for your questions. And I do appreciate it. There's another one coming up called Brain Health that we'll be showing in a few weeks, and it's going to talk about working your memory. It will have some of these slides in them about the function of the brain, because I think we have to understand that before. So it might be, for some of you, the beginning, a little bit of a repeat, but we're going to talk about exercising the brain and keeping the brain healthy and what we can do food-wise to make sure that our brain is healthy. So again, I appreciate you coming today, and looks like a beautiful day outside. Go out and enjoy the rest of your day. Thank you. And thank you, Emily.
Thank you, Chris, for a great presentation. And then, just a reminder, we have a 5-question survey that should pop up in your window once we end the webinar. So we'd appreciate if you could provide feedback for that survey. Everyone have a good day. Thank you.